Hey everyone, welcome. Today, we're going to dive deep into unit conversions by tackling a really classic problem from one of the best physics textbooks out there. I'm going to walk you through this powerful, step-by-step method that honestly will help you master pretty much any conversion challenge you come across.
And hey, a special shout out to all of you joining from the Step by Step Physics YouTube channel. I made this explainer just for you. We're jumping right into problem 4 from chapter 1 of Halliday and Resnick's Fundamentals of Physics, the 12th edition. Let's get into it. So here's our game plan. First, we'll look at the challenge itself. Then, we'll lay out all the clues the problem gives us. After that, we'll map out our conversion path. Then it's on to the fun part, solving part A for picas, and then part B for points. And we'll wrap it all up with the final takeaway, the big why behind this method. All right, first things first, the challenge. Before you even think about plugging in numbers, the most important step in any physics problem is to make sure you know exactly what's being asked. So here's the problem straight from the book. It says, spacing in this book was generally done in units of points and picas. 12 points equals 1 pica and 6 picas equals 1 inch. If a figure was misplaced in the page proofs by 0.80 centimeters, what was the misplacement in A, pica, and B, points? So really, our mission here is all about translation. We have to take this one measurement, 0.80 centimeters, and basically convert it into a completely different language, the language of typography, which uses picas and points. It's kind of like a fun code-breaking challenge, right? Okay, so every good plan starts with gathering your intel. Let's move on to our next section, laying out the clues. We need to figure out exactly what information we have to work with. So here are all the facts on the table. We're starting with a misplacement of 0.80 centimeters. The problem also gives us two key conversions. 12 points equal 1 pica and 6 picas equal 1 inch. But wait, do you see the little disconnect here? We're starting in centimeters, a metric unit, but the path forward involves inches. That means we need a bridge, a way to get from the metric system to the imperial system. And that bridge is our crucial third conversion. 1 inch is exactly 2.54 centimeters. Now that we have all our clues, it's time to build our roadmap. This is what I call the conversion path. It's our strategic plan of attack that will get us from the start to the finish without getting lost. Our strategy is a super clean 3-step chain. First, we're going to cross that bridge and convert our centimeters into inches. Then from inches, we'll convert to picas, and boom, that'll solve part A of the problem. And finally, we'll take that answer in picas and convert it into points, which will solve part B. See, it's a perfect logical flow. Okay, enough planning. It's time to execute. Let's get to calculating. We are on to part A, solving for picas. So here's how we set up the math. We start with what we were given, 0.80 centimeters. Then we multiply by our conversion factors, which we write as fractions. Now this is the really cool part. We arrange them so that the units we don't want cancel out. See how we have centimeters on the top here and centimeters on the bottom there? They cancel. Then inches on the top, inches on the bottom. They cancel too. And what are we left with? Picas, exactly what we wanted. And when we run that through the calculator, that's 0.80 divided by 2.54 and then multiplied by 6, we get our answer for part A. The misplacement is 1.9 picas. Awesome! Part A is in the bag. Now let's build on that result to get our final answer. It's time for part B, solving for points. This next step is actually even simpler. We just take our answer from part A, the 1.9 picas, and we multiply it by our final conversion factor, which is 12 points for every 1 pica. And again, let the units be your guide. Picas on the top cancels with pica on the bottom, leaving us with our target unit, points. The calculation gives us our final answer for part B. The misplacement is 23 points. And just like that, the entire problem is solved. So we got the answers, which is great, but let's take a second to talk about the big idea here. Let's look at the final takeaway and really understand why this step-by-step method is so powerful and reliable. So let's just recap our journey for a second. We started with a pretty simple metric measurement, right? 0.80 centimeters. And we successfully translated into a totally different system that's used in publishing, ending up with 1.9 picas and 23 points. You know, this powerhouse technique we've been using has a name. It's called dimensional analysis. And you can honestly think of it as the grammar of physics. If you make sure your units cancel out correctly,
You're basically guaranteeing that your mathematical sentence is structured properly. It ensures your final answer always makes logical sense. It's a tool you can count on every single time. So I'll leave you with a question to chew on. We just worked with these old, maybe even obscure-sounding units. Why do you think points and picas are still around today? Especially in fields like graphic design and digital design, when the metric system is so common. It's a really interesting question about history, tradition, and technology. Thanks for joining me for this problem solve.